This is lesson 1.3, rates of change in linear and quadratic function for AP Precalculus Unit 1. A linear function. For any linear function, the average rate of change over any length of input, the value interval is a constant. We also think of this as the slope of the line, which we learned in Algebra 1. In example 1, we are given a table with selected values of a function, and the question asks, explain why the function f of x is not a linear function. So to know whether a function is a linear or is not a linear, we will analyze the difference of the y and the difference of x, which we're going to find the slope. So let's do the difference of x. 2 minus 1 is 1, positive 1. 4 minus 2 is 2. 8 minus 4 is 4. As you can see, the difference of x are not the same. Let's do the difference of y. F of x is y. So 7 minus 4 is 3. 10 minus 7 is 3. 13 minus 10 is also 3. As you can see, the difference of y is 3, and all 3 and the difference of x are different. 1, 2, and 3. So now let's analyze each from interval 1 to 2, 2 to 4, 4 to 8, and see if the slope are the same, because the value of the interval is a constant. That's what we're looking for. So the interval on the 1 and 2, we're only dealing with the x, is the difference of y is 3 divided by 1, so the answer is just 3. So now the interval on 2 to 4, the difference also will be 3, but the difference of x is 2. So that will be 3 over 2. As you can see that these two slopes are not the same. Let's test the last one. On 4, 8 will be 3 divided by 4. Because of the slope are not the same or is not a constant, then that's the reason that this table is not a linear function. That's all you needed to explain. It did not say show any other way. Just say explain. This is your justification, and then you will write based on the slope is not a linear function. That's all you have to say. You cannot say anything else. So now we have a quadratic function, and we need to complete a table over the consecutive equal length of the input, which is the interval given below, which is x, or the interval -3 to -1, -1 to 1, 3, and 5. Then it says, then complete the table for the average rate of change of g of x for each consecutive interval of equal length, which is the input values. So now let me write the given function at the bottom so we can see clearly. So the function given is g of x will be equal to x power 2. So I will take those value x and insert directly, and then see what the y function. G of x is just a y. Always if you see f of x, g of x, k of x, as the assumption is just a y. We're dealing with a y. So -3. -3 power 2 is 9. It's 9. -1. When x is -1, -1 power 2 is 1. 1. When x is 1, 1 power 2 is 1. Now x is 3. 3 power 2 is 9. Then 5. 5 power 2 is 25. So now we have the x and y values, so let's find the interval, the difference of x and the difference of y. So we know that 1 minus 9 is -8. 1 minus 1 is 0. 9 minus 1 is 8. and 25 minus 9 is 16. So let me do the difference of x. So -1, -3 is 2. 1 minus -1 is 2. 3 minus 1 also will be 2. 5 minus 3 will be 2. So you can see that the x value, the difference of x is constant, but the difference of y is not a constant, but we will test it average rate of change. So average rate of change is the difference of y divided by the difference of x. So it's a -8 divided by 2 is -4. Now the difference of y is from -1 to 1 is a 0 divided by 2, which is 0. The interval from 1 to 3 is 8 divided by 2 is 4. The interval between 3 and 5 is 16 divided by 2 is 8. As you can see, I have a -0, then 4. That shows this is a symmetry over -1 and 1. How do we know that? Let's test when x is -5. X is -5. So -5 power 2 is 25. 25. Then 9 minus 25 is -16. So the interval that we are looking for is a -5, -3. And the average rate of change is -16 divided by 2. Why? Because -3, -5 is also 2. So -16 divided by 2 is -8. You can see clearly from the 0 on the left is a negative number, which is the same number as the on the other side of the 0, which is the positive. So now what do you notice? We notice that rate of change is different. It is symmetry on the interval -1 and 1, -1 and 1, and it goes from positive to negative. That's all you needed to explain. But it says, what do you notice? It didn't say explain. It just, we notice that the rate of change is different, and it's a symmetry on the interval -1 and 1. It changes from positive to a negative. So now we are given 3 different tables which has selected values of various functions are given the table. For each table, determine whether if the function is a linear, quadratic, or neither. To know the linear, we check the first difference. If the first difference are the same or slope are the same, then it's a linear. If it's not, we will test the second difference. If it's not, then we will say it's a neither. So now let's test the first difference. I'm writing it as a FD, which is first difference. So now 1 minus 0 is 1. 4 minus 1 is 3. 9 minus 4 is 5. Let me see the difference of the x. So 2 minus 1 is 1. 3 minus 2 is 1. 4 minus 3 is 1. Now we can see clearly the first difference is not the same. So we will do the second difference. We'll use the second difference. So 3 minus 1 is 2. 5 minus 3 is 2. As you can see, the second difference is constant, which is the same value, 2, 2. So 2 divided by 1 is 2, 2 divided by 1 is 2. Then this is a quadratic. Now let's do on B. The first difference. 1 minus 0 is 1. 4 minus 1 is 3. 9 minus 4 is 5. It's the same value that we have here. So 2 minus 1 is 1. 5 minus 2 is 3. 10 minus 5 is 5. So we can see that the first difference is not the same. And the first difference of the x are not the same. So we will test the slope. Slope is rise over run, or the difference of x divided by, difference of y divided by difference of x. 1 divided by 1 is 1. 3 divided by 3 is 1. 5 divided by 5 is 1. So this is a linear. So now let's find the difference of the x. 3 minus 1 is 2. 5 minus 3 is 2. 7 minus 5 is 2. So we can see clearly it's a constant, it's the same value, the difference. So now it's 1 minus 1 is 2. 2 minus 1 is 1. 2 minus 2 is 0. So the first difference is not the same. Always, if the first difference is not the same of the y and the first difference of x is the same, then we should test for the second difference. Then that way, then we can find whether it's a quadratic or not. But if the difference of the x is not the same and the first difference are not the same, just test if the slope is the same. If it's not, then we will do the second difference, and then that becomes a neither. So now then let's test the second difference. 1 minus 2 is negative 1. 0 minus 1 is a negative 1. So now we can see the second difference is the same, which is negative 1. And the first the difference of the x are the same. So the slope is negative 1 divided by 2. So this is a quadratic. This is a quadratic function. So now we have more on concavity, which we seen it earlier lesson, which is 1.2. We did see the concavity on section 1.1. So when is concave up a function? When the average rate of change, this is just the slope. We're just still talking the slope. When the average rate of change of an equal length input value interval is increasing it for all a small length of interval, not a large number, a small like 0.1, 0.2, something like that. Then if the interval is increasing it, then we have a concave up. When it's a concave down, the average of change, which is the slope also of an equal length input value interval, is decreasing for all a small length. We also should note that whenever we talk concavity, we're talking about the second difference, not the first difference. The second difference deals with concavity. So now let's test the difference of the x. So 1.1 minus 1 is 0.1. 1.2 minus 1.1 is 0.1. 1.3 minus 1.2 is 0.1. So now let's see the difference of the y or k of x. 1 minus 4 is negative 3. Negative 1 is negative 2. Negative 2, negative 1, negative 2, negative 1 is negative 1. This will be the first difference. Now we have to do the second difference because we're talking concavity. Second difference. So negative 2, negative 3 is negative 1. So 1 minus 4 is negative 3. Minus 1 is minus 2. Negative 2, positive 1 is negative 1. Negative 2, negative 3 is positive 1, not negative 1. It's a positive 1. Negative 1, negative 2 is positive 1. You can see that the second derivative is the same, which is 1 on 1, and it's a positive. This is a quadratic function. And if it's a positive, then we have concave up. It's a quadratic, but it's a concave up because it's a second derivative is a positive. Now we can see the x is the same value for the a, so we know the difference is 0.1. So now 4 minus 1 is 3. 7 minus 4 is 3. 10 minus 7 is 3. 4 minus 1 is a 3. 7 minus 4. So you can see that the first difference is the same, so we cannot do the second difference because we will end up at 0. So this is not, doesn't have a concavity because it's a linear. And no concavity. I'll write it here, concavity. No concavity because the first difference are the same. So now also on C is the same x value. We had A and B. So the difference of the x is 1. So 7 minus 1 is 6. 11 minus 7 is 4. 13 minus 11 is 2. So that will give us the first difference. So now let's do the second difference, since we can see that the first difference is not the same. So the second difference, 4 minus 6 is negative 2. 2 minus 4 is negative 2. We can see that the second difference is a negative. It's not a positive. We know it's a quadratic and concave down because y is a negative. Average rate of change is negative, whereas average rate of change here is a positive. That's all it says. Which function could be the concave up, concave down, or neither. This is a neither because it's a linear, but A and C are concave up and concave down. So now we have a different type of example. We are given a table with value of several quadratic functions. We were already told that the table belonged to a quadratic function, a selected value of x for each function. Find the value of the constant k in a table. Once we know it's a quadratic function, we will test the second derivative, not the first, the second difference, not the first difference. So the first difference is, so 2 minus 0 is 2, 4 minus 2 is 2, 6 minus 4 is 2, 8 minus 6 is 2. They're all positive 2. Now let's test the difference of y. 5 minus 0 is positive 5. 8 minus 5 is 3. 9 minus 8 is 1. K minus 9 is k minus 9. That's the k that we are looking for to find the value for k. Now the second difference. So 3 minus 5 is negative 2. 1 minus 3 is negative 2. Since we know this is a quadratic function, the second derivative must be the same. So what we have is k minus 9 minus 1. K minus 9 minus 1. So we will set k minus 9. To find the k value, we will set k minus 9 minus 1 equal negative 2. Must be equal to 2. Minus 9 minus 1 is at 10. So k minus 10 equal negative 2. To solve for k, we will add positive 10, and then we will add a positive 10 left and right. So the k, because minus 10 plus 10 is 0, negative 2 plus 10 is 8. So the k value is 8. So now we will find the difference of y. 5 minus 1 is 4. 9 minus 5 is 4. 13 minus 9 is 4. 17 minus 13 is 4. So now let's do the difference of the y, or m of x. Negative 1, negative 4 is negative 5. Negative 1, negative 1 is negative 3. K minus minus 4 is k plus 4. Minus 4 minus k is minus 4 minus k. That would be the first difference. Now let's do the second difference. So minus 3 minus minus 5 is positive 2. K plus 4 minus minus 3 is k plus 4 plus 3. We don't have to do this one because we know the second difference must be 2. So we will set it up. K plus 4 plus 3 equal to 2. Then 4 plus 3 is 7. K plus 7 equal to 2. So to solve for k, we will subtract 7 left and right. So k will be equal to negative 5. And you can put the k value here. Minus 5 plus 4 and minus 4 minus minus 5. So now we know the difference between 2.5 to 2.1 is 0.4. And then we know all are 2.4 because from 2.5 to 2.9 is 0.4. 2.9 to 3.3 is a 0.4. 3.3 to 3.7 is 0.4. So we only worry about the difference of the y. K minus minus 2 is k plus 2. 12 minus k is 12 minus k. 16 minus 12 is 4. 18 minus 16 is 2. That would be the first difference. Now let's do the second difference. So k minus minus 2, 12 minus k. We cannot do the k, so we will do we will test for the value here. 2 minus 4 is negative 2. Then 4 minus 12, it will be 4 minus 12 minus k. Always you just look for where you can find the value easily. We cannot do 12 minus k plus 2. So it's better we start at the bottom and then move upward and then set those two difference equal so we can find the k value. So now we have 4 4 minus 12 minus k will be equal to negative 2. So we have a negative, 1 in the front of the parentheses. So 4 minus 1 times this minus 1 times that will give us plus 12. No, it's a negative, not a positive. So negative 1 times 12 is a negative 12. Negative 1 times negative k is a positive k equal negative 2. So 4 minus 12 is a negative 8 plus k equal negative 2. We will add 8 left and right. So k, 8 minus 8 is 0. Then k is equal to negative 2 plus 8 is 6. So k is 8. 8, k is negative 5. The last one is a 6.